Hello and welcome to our final session for today. I'm Sean Hunter, Content Director for Automotive EV, and delighted to be joined by Greg Archer, UK Director for Transport and Environment, Robert Falck, Chief Executive Officer of Einride, Rodney Salmon, VP Automotive EMEA for IPL Macro Salmon, Bill Kascel, Senior VP Sustainability for Kuehne Nagel. Thank you, gentlemen. For this session, I'm going to be handing the reins over to Greg, who's going to steer you through. I may pop back in at the end with some questions. So if you do have a question for the panel, please don't be shy. Make sure that you put it forward and we'll ask them. And if it's a very difficult question, all the better. So thank you very much, gentlemen. And this is where I hand over to you, Greg. Thank you.
Well, thank you very much, Sean, and thank you to the participants in this session and to the audience out there in your homes and offices. I'm Greg Archer. I'm the UK Director of the Environmental Group, Transport and Environment. T&E has been in existence now for 30 years, working on the shift to low and zero carbon vehicles and fuels, and also how to decarbonise aviation and shipping. And we've got an extensive programme of work in Brussels and in our national offices to do that, including a great deal of work recently on things like the EU truck CO2 regulations. It falls on me to provide some context for this afternoon's discussions, and I have a few slides to help me to do that. I think the first point to bear in mind here is that the decision last year of the UK to achieve net zero emissions by 2050 really means that for road transport, cars, vans, trucks, buses, those sectors need to be zero emission by 2050. Any offsetting that will be done will be needed for agriculture and for aviation. So cars, vans, trucks, they'll need to be zero emission within 30 years. And if we're going to achieve those kinds of cuts, we're going to have some really radical reductions in emissions overall. As the slide illustrates, around a third of all of the UK's greenhouse gas emissions are now coming from transport. And that includes nearly 14% coming from cars, 4% each coming from vans and trucks, and nearly 11% coming from the aviation and maritime sectors. We now have, I think, a pathway to be able to decarbonise our cars and vans. It's going to be battery electric vehicles to a very large extent, powered with renewable electricity, charging their batteries to enable them to get around. And the government has committed to phasing out the sale of all new cars and vans by 2035 at the latest. And if you read the papers, you'll probably see that there's a lot of talk about bringing forward that target to 2030 when the Prime Minister speaks on this, possibly as early as next week. But freight presents an even bigger challenge overall. The gas industry certainly argues that we should be using natural gas. But when we look at the detail of that, we find that in reality, it's very difficult, that there are no significant CO2 savings using natural fossil gas over diesel fuel. Some argue that we should be focusing on the efficiency of the system, creating more efficient diesel trucks, increasing the average load, introducing mega trucks, and switching as much freight as we can onto road and off of road and onto rail and waterborne systems. But actually, if we look, as T&E have done over the last few months at this, whilst these are all valuable CO2 savings, they can't deliver the zero emissions which we actually need. In fact, even really aggressive efficiency measures will only deliver about a 16% reduction in CO2 emissions by 2050, leaving nearly 18 megatons in the freight sector to be resolved. So what is the solution going to be? Well, certainly recently there's been a great deal of talk about hydrogen. and using hydrogen to power our trucks in particular. But the problem with hydrogen is that it's a very inefficient process to generate all the hydrogen that we actually need. Indeed, only about 1 in 3 of the renewable electrons actually goes to produce useful power. So if we were going to shift all of our trucks over to hydrogen, what we would find is we would need to be producing nearly 125 terawatt hours of power just to produce all that hydrogen for trucks. And to put that into context, that's around a third of the UK's total current generating capacity. The oil industry argues that no, maybe hydrogen could have a role, but in fact, the bigger solutions are lying in synthetic diesels. Now, we can certainly produce those. The reactions and chemistry has been around for nearly 100 years. But again, we need vast quantities of renewable power in order to do that. In fact, if we were to convert the entire UK truck fleet to synthetic diesel, we'd need so much renewable power that it would represent nearly 60% of the total generation of power in the UK today. So it's beginning to look more like that if we are going to shift, as we have to zero emission freight, then a big proportion of that is going to have to come through electrification directly. But this presents a huge challenge to us. There are very few electric vans and even fewer electric trucks available to buy today. There's no recharging infrastructure, and clearly the commercial case is not there at the present time. So T&E has been working on this challenge over the last few months and really thinks that what we should be doing is starting with the low-hanging fruit, to take steps towards this transition over the next decade or so. We have, to begin with, to focus on urban and local regional deliveries, trips which are perhaps under 100 or 125 miles, ones where the truck can be recharged at the depot at the beginning or end of the day or partway through its trip. And once we've gone on and started to shift to electric trucks in that urban and regional delivery space, we can then start to expand that with a more extensive public recharging network to enable widespread use of electric trucks in our urban areas, before we finally, at some later stage, begin to tackle the much more difficult problem of long haul, where maybe biomethane, maybe synthetic diesel, maybe hydrogen could have a role alongside electric trucks, maybe operating with catenary systems or fast charging. One of the things for sure in this debate is that we need to get started. We can't sit around any longer and wait for a golden bullet to emerge. We're going to have to start making changes to our freight system today. And I'm delighted that to begin with, we're going to hear from one company that is really starting to do that in a significant way. Robert Falck is the CEO of Einride, and he will be telling you about their electric and autonomous pod system. So Robert, over to you.
Thank you. And I think that we already have some points for discussions here, and it's lovely to have and always be in these kinds of conversation. The benefits and the perks of creating a future and discussing the future is it's a constant, ongoing source of debate. And at Einride, I'm trying to share here, and as always, to be, so to say, working in the tech industry, you always are supposed to be really, really good at tech. So I will try to share here. Hopefully you can see my screen now. Anyone see my screen?
Yeah.
Great. So we started Einride. I have a background from the automotive industry, and especially in the production and manufacturing of heavy trucks. And I used to be head of global manufacturing engineering for all the powertrain, overseeing all the industrialization of new powertrains. And my realization and understanding of the industry was that the changes, what needs to change is more on the logistics sides and the system side than anything else. New technology will make us rethink the whole logistics setup. And the conclusion was literally that at the core, we are going from a mechanical system, because a diesel engine is a mechanical system, and to an electric and digital system. So it's not that far off from the same transition we saw them back in the days when we went from mechanical machine calculators to electric calculators. It's literally the same transitional and technology shift that's ongoing. And you can always debate exactly the numbers, but freight transport is one of the biggest contributors to CO2 emissions globally, and it consumes most of the oil. And I don't think that the transport system itself or the logistics system itself is very efficient. And I think that the legislative structure and the legislative market is one of the major driver behind it. So we started Einride with the ambition to rethink the whole transport setup. And what we created is an autonomous electric transport system that literally see transport as a system, not as a standalone vehicle. So what we do is the same logic and setup as you actually do inside factories, inside all kinds of systems. Already today, most of freight at one point is transported with autonomous electric transport system. And we extended the same logic and setup to a new context. And this is live in Sweden. It is something we do. And the best benefits for this is actually not in the close range. The best benefit, the most lucrative setup for this is on the middle and long haul setups, where you can have direct and long haul deliveries at a very cost competitive solution without the need of consolidation and need of big, also big setups. And if you start to calculate it, I think that the future is smaller, more direct, just-in-time deliveries instead of consolidated big trains. And I think that UK will be especially good for this kind of solutions. So what we've done is, instead of working from the technology from a perspective of making yet another truck, we've taken the position of how would you design and develop a transport system if you did it from scratch. And what we did is literally start with the customer needs, and based on that, we've done literally the modeling and setup for how to run and execute a transport system. Firstly, electric, but then electric and autonomous. And with that, we can work. We work with several Fortune 500 companies for developing and doing a strategy for how they can go electric. So our customers is not the carriers or the ones who buys the trucks that dominates markets today. Our clients is the big companies, where the shippers of the world, where we work for how to go provide them with electric and electric autonomous transport solutions. And we truly believe that the industry will change. And we think that the long haul and the setup that for transport we see today is going to make the world look very different. And if you look historically, and I think especially countries like the UK and most of Europe has been built on different transport needs and transport solutions. And I think that the future electric and autonomous transport solution will be extremely beneficial for all of us. Thank you. Can you still hear me?
Yes.
Thank you. That was my quick introduction.
Okay, I'm sorry. I think there was a problem with my microphone, but over to please to Bill now on their commitment to sustainability in logistics.
Thank you, Greg. Hello, my name is Bill Kascel. I am the Senior Vice President of Sustainability Solutions North America for Kuehne Nagel. I have been with Kuehne Nagel a few weeks short of 40 years. Next slide. Nobody expected the logistics guy to be good at this, so that's why I asked for Sean's help. Thanks, Sean. So just giving you a snapshot of the global CO2 emissions. Greg showed you what the UK is. So transportation, that general bucket, makes up 23%. 8% of that, though, is trade related to the freight transport. As Kuehne Nagel is one of the largest LLPs in the world and the largest NVOCC, we take this responsibility to heart. That's maybe why people were asking, why is a logistics guy on this? In our program, we are going to be net zero carbon by 2020 for our scopes 1 and 2, and by 2030 for scope 3. For us, scope 3 includes all of our travel by trade, all of our logistics activities, and even our commuting. And this makes up 93% of our load. Next slide.
Apologies, sorry, I don't know why that's done that.
Thank you. So this gives you just a little bit better of a look at what the different modes of transport emit. And in our global logistics view, obviously we do very little rail. We have some of the rail that we do within countries, and of course the Asia-Euro rail system, but globally, the biggest part of our CO2 footprint is in air freight and sea freight logistics. So showing here the part of our responsibility, obviously in the past, and I say that jokingly, we were part of that 81% of CO2 that was attributed to passenger operations because we traveled maniacally. Now we're using Zoom. We're really looking to cut down our footprint in any way we can. But belly freight and dedicated freighter is still a good chunk of the CO2 emissions we take responsibility for. The other one, being the world's largest NVOCC, is of course sea freight logistics. Now, only 23% of the amount of CO2 attributed to sea freight is container shipping, and that's really the domain of Kuehne Nagel. That's where we operate the most. It's the most eco-friendly transport, and obviously, being the largest NVOCC, it's where we're focusing a lot of our attention. Next slide. Sorry, I went blank there for a second. So how are we trying to help? I drive an EV. I am trying to get all my colleagues to drive EVs. I think it's one of those things that you have to experience it to accept it. But what we're really trying to do with our customer base is join us in the fight against the, like I said, the proliferation of CO2. One of the tools that we've come up with is a platform that we call Sea Explorer. Really quick on this slide, what I just wanted to demonstrate is the fact that there are different slings in the world. So we have tracked every one of the sea freight slings out there, and we had to nickname them because some of them are, how can I put it? There are many containers from different companies on the same vessel and many vessels on the same sling. So we put little nicknames to them here. You see that the two we show you for this example are Beluga. Simply moving from one sling to another can create a savings in CO2 upwards of 40 to 50%. So with our tool, we can show our customers, here's what you are doing, here's what you can do, and try to get out in front and slow down the CO2 proliferation. Like I said, if we can start by just reducing, it's a great move. the moves after this will, opposed to somewhat what Greg was talking about, will have to be the silver bullet for the sea freight industry is probably got to be biofuel. I know that some of the lines have experimented with what I called hybrid ships, electric batteries to a certain degree, but at this point, the technology is not there for it to be a complete electric ship on air freight. I know Airbus is dramatically stating that they'll be ready 2030, 2035 with electric planes. Everybody out there, raise your hand if you want to be the first passenger. I think that's something that we're going to have to wait a bit for as sustainable airline fuel. But our first job is reduction, and then we have to allow technology to help us get the rest of the way. Final slide. So what we ask our customers and our vendors is to help us, to be the responsible stewards of our planet, and to do everything they can to assist us in reducing the CO2 footprint that our industry leaves behind. Thank you very much.
Bill, thank you very much. And my apologies for my failing mic a little earlier.
No problem.
That gives us a really good flavor of what one of the really big operators are doing in the space. But part of this is all about drilling down into the detail. And our final presentation this afternoon is by Rodney Salmon, who's going to tell us a little bit more about how we can be reducing emissions by changing some of that important packaging that gets carried around. Rodney.
Yeah, good afternoon, everyone. Thank you for your attention. Mine is a session where a lot of what we've seen is stuff that a lot has to happen, and a lot of basically innovation and a lot of money has to be put into it before it actually comes alive. What I'm talking about is savings on emissions, huge savings on emissions that can actually happen right now, okay, at no cost. So it's got everybody's attention, I hope, because what I'm going to talk about is really understanding of how we can take responsibility. And as Bill said, you know, it's the visibility there, but to be able to see the reality of the savings on CO2 savings is important. So what I'm talking about really is the amount of steel stillages that are currently being used in the automotive supply chain and many supply chains. I think just in Europe alone, there's over 30 million steel stillages traveling around on different trucks and sea containers. And as Bill has informed me, also on air freight as well. So what I'm saying is basically is that we've just done a study with a large OEM on, they've identified 72,000 steel stillages that actually can be replaced immediately by 72,000 plastic and also lightweight folding containers. On average, they've said that each time we replace one of these items, we'll save around about 80 kilograms in weight. So the forecast they did was that during, if we got these 72,000 stillages and we changed them into a plastic or lightweight folding mechanism, to take exactly the same weight and similar component parts, we'd be saving basically 276 million kilograms of weight in trucks. We wouldn't necessarily reduce the amount of trucks because you still got to do the trips to the tier suppliers, from the tier suppliers to the OEMs, etc. But you'd be taking out 276 million kilos of weight out of these trucks. Now, we've been trying to find out exactly what kind of saving this will give this particular OEM is in reduced carbon savings. It's not an easy equation to find out exactly what the saving is when you take a kilogram out of a truck, how much emission savings you do over every 100 kilometers. And so we're still trying to find that information. So if anybody's listening into this at the moment that can help us with that equation, it would be much appreciated. But if you think that just 72,000 out of 25, 30 million stillages, the savings there are absolutely enormous. And there's no cost involved, okay, because the plastic or lightweight folding is similar, if not less cost than steel, and it can be done immediately now. So my message is to OEMs and tier suppliers whose packaging engineers are out there, you've got a magnificent opportunity here to reduce your CO2 emissions. As OEMs, we know that the fines that have been already paid out by the OEMs for emission failings, okay, is absolutely enormous. Here's something you can do right now, and I urge you to take action straight away. Thank you.
Rodney, thank you very much indeed for that. And that's clearly a great opportunity to be able to save some carbon today. If you do have any questions for any of our speakers, do send them in and we will ask them. Until we do, I'd like to begin by asking Robert. Robert, what stage are your autonomous pods now at in terms of their development? Where are they being actually used at the present time?
No, for our perspective, you have, instead of saying, I think that the best way to visualize is that if we don't see that autonomous will happen all at once, I think that the autonomous, especially in highly populated areas and busy city streets, will take quite a lot of time, especially for bigger vehicles. And we have specialized in literally taking it by case, just as you do for optimization in other contexts. And I think that one of the hurdles of the whole optimization of transport has been the legacy structure of that it should be about creating a medical AI that can drive better humans. And coming from the optimization and more down to earth, making something go from point A to B, we have taken a specializing, taking a those step-by-step approach. And like you saw in the picture, the best application and the one we're doing now is literally from the warehouse to a warehouse. And that solution is available today, and that's something we feel comfortable providing at the good and competitive solutions. And I think that we are increasing, and we are launching in a few weeks actually, that we feel comfortable to start to say ship this technology now. And of course, it's not going to be in all applications, and it's not going to be everywhere. But we are looking at the scaling phase and scaling over the next 5 to 10 years. And as everyone here said, it will take time, but our prediction is that at the end of this what is called in English? Is it decade? Yeah, probably.
Decade.
Yes, end of this decade, we will start to see them at I predict the S curve will be at the end of this decade. And I think the benefits and the business case behind it is definitely in the advantage of it.
So what would you see as some of the really promising early adopter segments that and applications that you're most focused on?
For us, is the really sweet spot for these kind of solutions we see is in the range of 100 kilometers up to 500 kilometers. That's really the sweet spot for these kind of solutions. And that's also the design and the setup, because we designed the whole transport system and solution for being literally a backbone system for transport rather than anything else. So we are looking at palleted goods as one of the, and of course e-commerce and such solutions and setups is really the best possible solution. And it's extremely interesting when you start to see the overall setup. And I think it's something that's extremely underrated is how beneficial it is when you combine autonomous and electric, because it's the technologies in itself is not 1 + 1. It's more that it's 1 + 1 becomes 3 in this case. And I think that also a very overrated discussion is, of course, the long haul market, because the long haul market is really a small segment of the whole transport industry. I think the extreme long haul markets is not more than maybe 3 to 4% of the complete transport volumes. So I think that's what we need to focus on to make this future electric and sustainable, is really to make the short haul and the backbone of transport electric.
Thank you very much. Bill,
Yes, sir.
moving on. I know you commented in particular that your view at the moment is that it's going to be biofuels that provide that alternative, sustainable alternative fuel source for the shipping sector in the medium to long term. But there has obviously been a great deal of concern about the use of biofuels in transport so far, the use of palm oil being widely used in vehicles, leading to widespread deforestation in Malaysia, Indonesia, and other places. And we hear a lot about the problems of now the deforestation in Latin America being driven by soy and by sugar. What makes you think that we can find enough sustainable sources of biofuels to be able to shift away from bunker fuels to biofuels for shipping?
Very, very good question.
You've gone, Bill.
It was a very good question.
I hope it wasn't
Country
too.
musician has toured for centuries in his tour buses on this kind of biofuel that's created from grains, created from soybeans, as you said. The one that we're interested in is abbreviated UCOM, used cooking oil methyl ester. This is a waste product. We jokingly call it the McDonald's French fry grease. This is the cleanest, absolutely, I mean, it's 90 to 100% CO2 neutral. It's got a very, very small footprint in its manufacture and transportation at this point, but that is kind of the magic question. How can you get enough of this and how can you distribute it? It's, like I said, it is a huge byproduct, unfortunately, from our diets and our cooking. But whether or not we can ramp this up to meet the growing needs in transportation is a good solid question. But we're always trying to look at the horizon, but also, the end of our nose. So as we see it, UCOM is the solution to make sure that we're not burning diesel fuel. We're looking at the problem in front of us. There's your CO2. So we are using this as a substitute. And hopefully, like I said, the technology will come to allow us to not use crops, not to waste farmland to create this, but to find more and more resources to create it.
I mean, UCOM is certainly a really excellent feedstock for biofuel. 80% of the biodiesel put into cars and trucks in the UK comes from UCOM. But of course, there has been a recent scandal in the Netherlands of people claiming that that oil is UCOM when it's actually virgin oil. There's a lot of controversy at the moment about the supply chains and whether or not we're genuinely getting used cooking oil or virgin oils and so forth. One of the other solutions that's being talked about a great deal at the moment is potentially ammonia. Is that something that you yourselves have been looking at all in shipping? No, not
No.
Look in your face.
No. It was mentioned earlier about liquefied natural gas, which CMA just launched 9, I believe there are 23,000 TEU ships on this, which again, in dealing with sulfur, fantastic, no sulfur problem, but only cuts into the CO2 by 15 to 20%. So the other, like I said, these are the main tools we have right now. There's, like I said, and again, I am a huge, I know where I'm talking, but I know who I am as well. I'm a huge advocate of batteries. I have a battery run lawnmower. I'm a freak on this technology. I just don't know, and I'm not the expert here, to know if that is really something in the future where the batteries can be small enough, efficient enough to move like I said, a 20,000 TEU ship from, say, Asia to the United States or Asia to Europe.
Yeah, it's certainly a very big question, and I know there's been whether or not it's possible or not. I think a big question. Certainly, there are now electric ferries that are plying between ports in Europe, but whether they'll ever be able to go those long distances over 20 miles or so, I think is a big question still. But thank you for that. Rodney, really interesting to hear about, you know, these low-hanging fruit which exist in terms of just reducing the weight of the materials that we're carrying around in our freight sector. What are the barriers at the moment that are really preventing these things being more widely used, and how can we start to overcome them?
I think the main barrier, to be quite honest, at the moment is the time that some of the packaging engineers have to change from what they've been used to, okay, and you know, changing over to a new style, a new type of packaging, okay, where a business case has to be raised, and sometimes they just don't have the time, and time is in essence an element, and this is where we see that the benefit for this is not just to come out of the OEMs and tier suppliers of the cost saving, but the element of saving here is also with the LLPs. You know, if they're taking this huge amount of weight out of their trucks, okay, every year, then there's big cost savings with regard to fuel, let alone CO2 savings. And so it's really a combination around the logistics supply chain of the LLPs, the OEMs and the tier suppliers saying, we've really got to adapt this and we've got to put some time into it. And also, obviously, there's a lot of packaging suppliers that will help with the business case where they can. But really, funnily enough, oddly, it's a lack of knowledge of what's available in the market and also time. That's the key element of changing from one thing. Okay, look, we've got this new part. It's very similar to the old part. Let's just use the same packaging we had before. And that's very easy to do. It's a lot less time. Changing to a new thing and doing a business case for it, okay, is time consuming. And that's what I feel at the moment is the main reason for the blockage.
Thanks very much. I mean, time is always a big challenge in this industry. It's such an efficient industry. There's so few people in reality employed in it to make these changes happen, and we can only hope that time will be found in the future. Can I broaden the discussion out a little bit and ask all of you? At the moment, we've got seeing an awful lot of progress, I think, in the passenger car sector with personal mobility. If we look at the UK, there's been a massive shift towards cycling during the coronavirus pandemic. We're seeing rising numbers of electric vehicles being sold every month. We're nearly, I think, the last quarter of this year, alternative fueled vehicles actually outsold diesels in the UK over the last 3 months, an astonishing statistic. Now that emissions are starting to fall from passenger cars and that sector, are you beginning to see more pressure coming onto the freight sector from politicians wanting you to take faster progress in terms of cutting your emissions? But perhaps I'll ask Bill first and then others can chip in. So is that political pressure now building for faster progress?
I hope I have a better answer for you in about 7 weeks. Unfortunately, no.
Right.
To put it into perspective for the international audience, gasoline in the United States is around $2.20 a gallon right now. Almost record lows in the last the last decade for sure. And Americans have fallen in love with large vehicles. SUVs outsell anything else in the country. And unfortunately, we have stagnated in EV sales in this country, I believe somewhere around 2%. So without government regulation, and when you leave people to their wants and desires, I think it's safe to say, as long as gasoline prices stay low, SUVs have a premium price over EVs have a premium price over SUVs, it's the consumer's choice. So until we get a government that does, try to do things logically, like get us back in the Paris Accord, et cetera, I really fear that we're not going to see a big difference here. And that's why I do see, especially being close to a port, I see a lot of semi-trucks rolling down the road every day. I compete with them on my commute to work. So anyone who can solve the long-term trucking problem is a friend of mine, because this is really an issue in the United States. We have, let me say it, inferior rail system. As the old joke goes, buy rail stock, they're not building anymore. It's really become the fallback for U.S. transportation. And like I said, I would love to see EV trucks that could go New York to Los Angeles, or at least maybe halfway and do an interchange. But unfortunately, until we get the government behind initiatives like what you see in Europe, I'm afraid America's kind of stuck in neutral.
So can I reply on that? Because
yeah, please do.
I actually think that US will be before Europe on this.
Okay, why do you think that?
Because of the trust numbers. And if you go, and the fact that US is leading the race when it comes to autonomous, and I think that when it comes to the cost of electricity, it's actually extremely going towards zero, and it will be quite rapidly deploying. And it's something that history has shown is that if there's a good business case, US will be there. And if it's not going to happen. And we're looking at in the next 10 years and the cost reduction of transport with potentially up to 70 to 80%. And I think that with those kind of prices in the context, we will see a rapid deployment in the US for this as well. And the whole American map is literally built on logistics. It's why you have the hub and literally a whole city interchange is literally a hub and spoke system.
Yes.
And I think that that will be extremely beneficial for electric autonomous. And the only holdback will be legislation. And I think that's also the reason why I think that the US will be before Europe, because I think the biggest challenge for Europe will be the European Union. Because I think that deployment autonomous in a European context will be a challenge. But I think that if you look at all the sunny states in the US, that legislation is extremely progressive already. So I don't think that we've been more than maybe tops 5 to 10 years before we see transport, autonomous and electric on all the sunny states in the US.
So you see the European Union really getting in the way of these developments in Europe at the present time?
I think that we are looking at a situation where we have the US that's literally controlling the development of autonomous, where they are really the front runners and they are controlling the software. And China is really the spearheading electric. And I think they are between 2 and 3 generations, industrially wise, ahead of anything we see in Europe. And if you merge the two technologies, it will be extremely, literally disruptive for the whole industry. And I think that will break to legislation. And I think that the slowest moving legislator in the world, or at least for the three competing markets, is definitely European. So I think that that will be one of the biggest challenges.
So you think that the slow pace of legislative development in the EU, and I worked in Brussels for 7 years and I know how slow it is, you think that's really going to hold Europe back in this area, whereas in the US, obviously, we've got state level regulation and a lot of states really pushing ahead fast, and clearly in China too, a much more nimble regulatory system.
Yeah, and that's definitely what I see from my perspective, is that our competitors on the autonomous side is in the US, and our competitors when it comes to electric is in China. And I think that's somewhere in between there. I think that, and also something very, very underrated in this discussion is, of course, that the legacy industry has big write-offs and big changes to do. And if you just look to the average OEM in a manufacturing spot, you're literally looking at between 5 to 7 years of write-off equivalent to the profit. So that's the kind of change we're looking at for the industry, and how tightly huge manufacturing in Europe is tied to Brussels. I think that that's going to be one of the challenges. And I think that it's as being a big European heart, I think that we should be challenging and pushing this change. I think that it's very important that we are very aware that that slow-moving bureaucracy that also are the benefits for us is one of our biggest challenges, especially if you want to be competitive in innovation.
Yeah.
And I'm actually quite, I wouldn't say scared, but I think it's not unlikely that a lot of European automotive industry will be challenged, especially from China, when it comes to electric, because they will be cheaper and better. And it's I know it's like swearing in church, we would say here in Sweden, but it's happening just as it did for the TV.
Well, thank you. It's a very, very good observation. Although I would say that I think there is a lot more investment in electrification in Europe now. I think there's been over 60 billion invested by European OEMs in the last couple of years. And the investment that was happening in China in 18 and 19, that money's now flowing into Europe. So it does seem to go in cycles, but it's certainly a big threat coming from the Chinese. Rodney, you talked earlier about the time pressures of being able to get these changes made. In your sector, are you seeing much pressure from the regulators to drive the sorts of more sustainable, lightweight materials that you were describing to us, or is this something that's being driven by business rather than by regulation?
It's being driven by business rather than regulation. I think this is, even although, you know, when you put it in a scale like I've put it, it is very high ratios and huge CO2 emissions can be saved. It certainly has to be driven within the sector. It has to be driven by the LLPs, by the OEMs, by the tier suppliers, and the packaging suppliers as well. You know, these are the people that are going to make it happen. These are the people who can make it happen now. Regulation, okay, will help simply because when in automotives, as you know, when you get to purchasing, okay, purchasing sometimes have their own rules and basically the cheapest product wins. What we are seeing now, which is a good change, is that sustainability is coming into the equation in a lot of purchasing decisions, and that's a major step forward in our industry when purchasing does look at this rather than buying from the cheapest product, but sees the life of the product is the most important of it, because it's no good in the packaging world producing a piece of packaging that has got to last for the life of the vehicle 7 to 8 years, when in actual fact it only lasts 2 to 3 years and has to be replaced. And if purchasing make that decision to go with the cheapest option, then that does happen a lot of the time, and it's missed because it's gone. And there's no real sustainability efforts into seeing why this has happened and putting it right for the next time. So it's really important going forward that the actual industry drives these initiatives and has the capabilities of driving these initiatives forward.
Thank you very much, and I think a really valid point we would all agree with. Sean, can I ask, have we got any questions coming in from the audience at all?
At the moment, I think you're actually keeping everybody at bay. You're really covering quite a lot of ground here, actually. Unless there's, I've got a couple of questions that I can put forward, but unless there's something else that you want to carry on with, Greg,
please put something forward, and we'll pick up on mine in a moment.
Yeah, no problem. So, with regards to shipping and sustainable shipping, are we a very long way off before we look to moving to kind of alternative fuel systems with it? With regards to maybe electrification on these ships is just too far a step to make. Are we looking at hydrogen systems possibly within these ships? Is that on the radar at all at the moment, or are we just saying at the moment we just have to make good of what we've got?
No, all of the major steamship lines have some, and I underline some focus, some more than others. AP Moller, the Danes have really put together a consortium that say that they can probably get there by 2030. CGM in France has like I said, aside from their new ships, the liquefied natural gas, have really put a strong push on biofuels as well. So I don't know that it's any more than, say, 10 years away. I can't speak on the electric because, like I said, I know that, for example, Maersk did a few ships like that, but then their focus seems to have changed. Whether that means that's their view on technology or they're just going with the flow, I'm not quite sure. But really, like I said, when you're talking long haul shipping across oceans, you really need a strong, dependable power source. And I think the real challenge right now that's coming up and that will slow biofuel is obviously you've got to get production up to a point where you bring the price down, and you have to have the distribution. It can't just be at 4 major ports in the world. You have to hit all of them.
I mean, if I can just chip in, I mean, from Transport and Environment's perspective, I think our view is that this initial shift towards gas is really quite counterproductive. We're seeing a lot of money beginning to be invested in the infrastructure and in the switchover to natural gas ships, but that doesn't doesn't create the emissions reductions which we need to get to zero emissions. And if people start investing in infrastructure and ships to be powered on gas, they're going to run those vessels around for the next 30 years. And realistically, that the emissions coming from them are still going to be fossil gas emissions. So we've got to be looking at other alternatives now. I think hydrogen is a really interesting opportunity in shipping. And I think off the back of that, ammonia and creating ammonia as well, that could either be burnt or used in fuel cells is another really interesting development in the sector that could get us towards zero emission if that hydrogen's being produced renewably. But I think a lot of the question is, you know, as an economy, we've got to make some really tough decisions about what we're going to use in particular to replace our natural gas. And if we are going to move towards hydrogen, then we will be producing hydrogen on such a scale that I think it can be cost effective to then put it into things like trucks or into ships. But if we don't make the decision to go for hydrogen instead of gas for domestic heating where it's being used, then that hydrogen is going to remain really expensive. And in that case, we're probably going to be looking at other solutions, maybe synthetic fuels, maybe biofuels, or indeed maybe, as we've seen in some cases, even wind coming back in one or two places. But Sean, did you have any other questions?
One more, I guess, really, and I think this is probably a little bit for everyone, talking about low-hanging fruit, and kind of what's achievable within the short term. What are we missing? Something that was within logistics and supply chain a while back was talking about platooning and the savings that can be made on energy output by utilising this technology. But we needed to utilise more recent technologies to make sure that it was being done in an effective and safe way. Is this something that maybe Kuehne Nagel and possibly one for Robert at Einride as well? Are these being explored for the future? Are these things that we're working towards? Are they going to be giving us actual real gains in the real world?
I think that actually platooning is a very interesting study or case, because when you break it down, the numbers and economics behind it doesn't really make sense. And I think that if you look at both the practical aspects of platooning and getting to get it done in real operations, and I think that we have seen a lot of cancellations when it comes to platooning cases lately. And I think it has to do when you're actually looking at real deployments, the increased utilization or the increased consolidation and planning, the increased complexity that you add when trying to add platooning and actual flow is actually makes very little sense, because we're looking at a system that's actually at its core already are with vehicles with low utilization, and we're looking at low fill rate in the whole overall system. And to increase the, so to say, the need for even further consolidation wouldn't make that much sense. If you look at more complex flows, like in factories and in more like high utilization, you actually see that what you want to do is to decrease the shipping size and you want to make it more direct and you want to do it more just in time, and that makes better flows and better utilization of the complete transport system. And I think that the tuning took us in the wrong way, and that's, for instance, why I think that the super trains is also taking you in the wrong direction. I'm not saying that it's not applicable in some distance. I think that Australia would be an extremely bad case of smaller, more direct shipments. But if you look for Europe, for instance, it's actually the freight system there is literally could benefit a lot for being smaller, more agile, and more flexible. And to further, so to say, consolidate transport makes very little sense with the fill rate we have.
Really interesting points you're making there, Robert. Thank you very much. Bill, did you want to chip in?
No, I can, again, I'm speaking as the American. I agree with them. I think that the platooning system isn't something that we're looking at. I mean, when we talk about again sustainability and CO2, the first things we talk about are just the intelligent things. Like I said, you know, try to be on the more efficient ship. Try to, as I say, try to find the way to spend the least CO2.
So we're coming to the end. I've got a question for everybody just to wrap up. Can you tell me what do you think would be the one single thing that would enable you to be more effective in either, you know, rolling out your autonomous electric trucks in the case of Robert, or bringing down the CO2 emissions from your operations in the case of Bill, or increasing the uptake of low weight systems for packaging? What single thing would make the biggest difference to you in terms of really being able to make an impact and starting to bring down the emissions? Why don't you start?
I'll jump in quick. To us, it's technology. I like to say that businesses and governments can jointly change behavior or create behavior. But I think when you talk about from a global point of view, to Robert's talk about maybe some of the dysfunction in the EU, you also have to remember you have 50 states in the United States, and one state can always change what the regulation is to just irritate the other 49. Technology is what is going to be the driver. As I said, if we can technologically create biofuel, very inexpensive, it takes the biggest bulk, which is sea freight shipping, which is the largest shipping mode in the world.
Technology for you. What would you say, Rodney? Are you muted, Rodney?
My fault, sorry. Yeah, it's people. Technology is there. The infrastructure's there. It's people and time, and a drive from the OEMs and the tier suppliers to actually put this easy solve solution of sustainability savings, okay, into the system immediately. And it is simple. Sorry, but to put it like that, but it is people and it's time.
People and time. Okay, technology, people and time. Robert, what's the single thing that would make the biggest difference to your business?
I think that something that's also very underrated is that we are saying that we want to change, but when it comes to actually doing change, we are all addicted to the fossil fuel value chain. And I think that that addiction doesn't go away without the struggle. So I think we need all to go to rehab. No, but all jokes aside, I think that the change need to come from within. And I think that especially from the politician side, I think that a lot of the technologies is actually there. I normally say that what we need is a leveled playing field, because the subsidies and the support has gone into the fossil fuel-based transport system for the last 100 years. And what we need with new technology is literally just give us the same opportunity and possibility as everyone else?
Well, that's three, I think, really great answers. We've got people, we've got technology, and we've got regulation and taxes to level that playing field and get that technology into the market and defeat the legacy operators. Our time is up. I'd really like to thank all three of our excellent panelists and speakers this afternoon. I've had a really interesting time hearing you and your answers, and I hope the rest of the conference proceeds really well, and I'll pass back to Sean just to wrap up. But thank you very much from me, and good evening.
Thank you, Greg.
Thank you.
Thank you very much from me as well, and a special thank you, Greg, for leading that panel. Very well done, and I think it's very interesting. That brings us to the end of our presentations for today. Thank you for joining us. We're back again at 8:50 BST tomorrow morning. We've got another full day packed out for you, and then we lead into Friday. So hope you can join us. Once again, thank you, panelists. Thank you for joining us. Bye-bye.
Thank you.
Bye-bye.